Hi. Uh, what are you supposed to send me? Do you have you send me your data? Is it okay? Have I ever processed your data before? Oh, this is the first time I'm looking at it. Wait, hang on, okay, all right. This one is your data. Okay. Got a couple of problems though. What's your argue again? Uh, surface area versus how do you measure velocity? What's your huh? Dude, that's not right. That's not right. What? Wait, hang on, yours is a parachute, is it? Parachute, parachute. And you want to use Suvet, but there's air resistance, and air resistance causes the acceleration to change. You can only use Suvet when acceleration is constant, right? Yeah. So if acceleration keeps changing, how can you use Suvet? You can't. No way. There's no way that you can use Suvet when your acceleration keeps changing, right? It's like so I was expecting you to I was expecting you to say that you assume terminal velocity. Then it's just speed equals the distance over time. That's all. Not Suvet, because Suvet is that means you're still assuming there's acceleration, but the acceleration is changing all the time. It's a moving target. You can't do Suvet using this. Did you just take distance over just take total height divided by time? Was that all you did? Okay, then that's not Suvet. That's just speed equals the distance over time. Okay. But that means your biggest assumption is it reached terminal velocity very quickly. Or you can do this. You can, okay, what was the greatest height that you dropped from? One more time. 4.62 meters. Okay. What you can do is that, okay, how do you measure the time? Take a video, right? Take video. Okay. Can you claim that you dropped from 5 meters and you only started recording the time from the 4.5 meter mark onwards? The idea of this is to state that you allow it some time to reach terminal velocity, then you assume that for the remaining height here is terminal velocity. Yeah, 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 something like that. Okay, all right. But okay. So I'm assuming that your times are all legit, right? Okay, so that's a bit unfortunate because that means we sort of like have to tweak something like, for example, wait, what's this? Why is it 9.24? There, up there, here. Oh, okay, 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 okay. Huh? But then your U is zero. But then again, you have another problem. You're assuming that's accelerating again. Yeah, because we have to approach this. Yeah, cannot lah. The acceleration keeps changing lah for parachute. So we cannot assume a wait. The teacher never. Uh, wow, so frustrating eh. I have to go and fix all these problems because someone's gonna mark, right, and someone's gonna ask questions like this, right? They're gonna be like, why are you using that? Uh, okay, okay. I'm sorry, but you understand that we have to tweak some values, right? Okay, okay. The other problem is only two trials. That's not good enough, lah. Okay, you know why? Because your type of experiment, right, is easily replicable, right? I can once you make the parachute, you can drop it 10 times if you want. Why you only drop two, right? So we're gonna have to kind of like RNG some numbers. Okay, I'll think of some. I'll do something here first. But I think I need you to get on the same page as me for this one here. All right. I understand that your this one here is the time taken to drop the 4.62 meters, right? Okay. Obviously, you dropped it. Yes, there's some acceleration. Um, unless unless right, if you want to do it the legit way, Jamie. Okay, let's say okay, I give you an option. Okay, you think about it, whether you want to do this. Okay, let me just illustrate this for you. So you did say 4.62. Let me use one of the times as the example. So 1.433. So this is 1.433 seconds, right, to fall. Okay. The idea is it fell, right? Definitely there's acceleration because we know that the initial is accelerating, right? But maybe we can assume that at some point later it reaches terminal velocity, right? at let's say this point here like this, right? But we don't know, right? So we can only kind of like just estimate. So the question is, do you think if you want to, can you go back to your video analysis and find the last 3 meters instead of the full 4.62? That's possible? Okay. No, as in like I'm asking you whether you think that that's something that you are okay to do. Yeah, get 3 meters. Okay, I'm also not very good at using the Logger Pro Analyzer. SJI loves to use the Logger Pro Analyzer. It's like their darling, right? As long as you use it right, like teachers will be very happy on. Okay, but let me ask you this, okay? But actually, all you did with that video, right, was to you just determine what was the time taken only, right? You just watch the frames, right? You can do that on iPhone also, right? Um, Okay, can. Um, which also means that I don't have anything to process at this point in time. Uh, Wait, let me think first. Let me think about whether I can help you process it. Uh, okay, what I can do is let's assume I'm gonna just use the cells here, and let's assume that these are the times for the 3 meters. Okay, then I'll process this whole thing for you because I can tell that you also know how to use Excel, right? Which also means that you are proficient in the formula bars and all that, right? So what I'll do is I will just process the things for you first, come up with a graph, and it's likely that once you when you have keyed in the proper values, the graph will automatically change also. Okay, so since we have a bit of time, do you mind if I do it now? Okay, mm. That one it depends on uncertainty. That's my job. I'm doing that for you too. Yes, that's why I'm doing this now. Okay, so don't worry. Um, okay. So assuming that your video analyzer is 120 frames per second, one divided by 120, you have a uncertainty of 0.008, right? That means you can key in up to 3 decimal places of this timing, okay? But I know that you selected it directly from the video analyzer, right? The video analyzer, okay. So we will just assume that the video analyzer's uncertainty for the time is plus minus 0.001. 001. It is, huh? Yeah. Okay, so this is uncertainty. Okay, just take note, have I sent you any sample reports before? I haven't. Okay, okay. I have to send you something. Please next time if you I think I said it before. So if you remember me saying it, just chase me for it, okay? All right. Yeah, really, really. It's like the Astro thing. I know you're going through a lot of Astro shit in school right now, and it's damn confusing, right? Yeah. Chase me. Like tell me that you don't understand anything for Astro. I'm going to create a separate class for Astro. That means I'm gonna ask you all to attend that class. Right? Because once I start doing the other options for the main classes, right, you can't attend the main classes. You have to like either skip those weeks or attend another class that I will hold for you guys, right? I have to go and find out one round again which days you are free. Yeah. Okay, hang on. This width, right? When you say width means what? Diameter, is it? Your parachute is a square. Uh, Wait, so what does width mean? Oh, yeah, lah, just say length lah. That's why I'm wondering what width means. Just say length of square, okay? Yeah, yeah, yeah. I was like wondering what is this? Okay, what do you use to measure? Ah, so these are in meters, Wait, so you have to present it to three decimal places because ruler also plus minus 0.001 meter. Okay. Technically, you can use vernier caliper, but I think vernier caliper maximum is only until 15 cm. So never mind. Okay, we use ruler. Okay. So all your these values here, right? I'm gonna highlight in green, right? So you have to go and fill them up yourself. Hang on, All right. So what I'll do is I'll just reuse the timings here. So it's obviously like not correct one, right? And then we key in. So we say we do 5 trials, okay? So you have to go and huh? What? Jamie? Yeah. So we say we do 5 trials. I know you only do two, so you have to go and random generate all the other three, Right? Okay, I'm gonna do your uncertainty now. Uncertainty or average time. So I'm just showing you how it's done. Um, but I think you're quite proficient at it, so I'll just do it very quickly. So I'm going to choose the maximum of these five values, minus away the minimum of these five values, right? And then the whole thing divided by 2. Right, so these are all your uncertainties. I need to check the number of decimal places. Hang on. So they're all 3DP. Okay. Absolute uncertainties must be rounded off to 1SF. Right. So that's why I put 1SF at the bottom here. Right. Over there. And then the average time must be rounded off to the same DP as your uncertainty. So DP follow uncertainty, right? So that's why it's all three DPs here. You got that? Okay. So any particular reason why you're doing V square and 1 over area? Okay. Am I correct to assume that this V square is truly the um, terminal velocity? It has to be, right? Because I think the guy who created the mathematical model would understand that a parachute would fall at different speeds until the terminal velocity is constant. So the model should only fit for terminal velocity. Otherwise, what V are we going to use, right? Okay, so okay, and okay, so what we're going to do is wait, wait, I need to insert this one first. Sorry, this is uncertainty of length, and this is 0.01 because all these have to go into the graph later. All right. So the V here, what I'm going to do is I'm going to get rid of this. I'm going to just take this equals to 3 meters. So again, 3 meters, we I think it's a safe assumption. Um, but I want okay, so I don't know whether you are comfortable doing this. Some students are not. But you might want to just like tell your teacher that your plan has changed and you are using only the time taken for the last 3 meters. Okay, just keep insisting that, oh, I'm using the video analyzer, it's such a great tool. Just kind of like, fake him a bit, right? Say, wow, you know what, Mr. Don't know what his name. Um, it turns out that the video analyzer is so cool. I realized that, in order to get the terminal velocity, I must assume that it reaches terminal velocity at some point. So I only took the last 3 meters, right? And the video analyzer is so good because I can measure out the 3 meters and then I can take the time for those 3 meters only, right? Wow, thankfully we use the video analyzer. You know what I mean? You say like that, right? Then the fellow will be, oh yeah, 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 yeah. Okay, so this is divided by the time, right? That will be the velocity. Ayo. And then this one is equals to this one to the power two. Okay, let me just sort out the. Okay, Um, so let me just show you the sample calculations for V. V equals to height of 3 meters, right, over the drop time. Okay, the drop time. So del V over V is equals to del H over H plus del T over T. Okay, right? We're gonna have to assume that the del H, right? So H is equals to 3.000 meters, right? Say you use a measuring tape, right? Then the del H, because you use a measuring tape, 0.001 meters, right? 1 mm is the uncertainty. Okay, and actually you can be conservative and say that, because of, I don't know, maybe parallax error and all that, you can give it 0.005. But if you're, I mean, if you put it down, your teacher doesn't say anything, doesn't say like, oh, what if there's something wrong? Then you just keep it at 0.001 first. Okay, this one here. So that means that del V is equals to V times del H over H plus del T over T. I'm going to screenshot this for you to use this as a sample calculation. Right? Yes, I have to send you a trial, sorry, not trial. I have to send you a IA sample so that you know what to put in, right? The format and all. Just please remind to chase me if I don't come back to you. Okay, right, then this is uncertainty of V, uncertainty of V. So this one is equals to V times del H over H. So 0.001 over 3 meters, because that's constant for all the other terminal velocities also. Then then plus del T, uncertainty of time, over the actual time itself. Oh, okay, yeah, correct. Okay. So these are your values. All right, let's do a quick check. All right, because we need to round this off to, we need to round this off to 1SF. So rounding it off to 1SF. Okay, and all of them are all 3dps. So my velocities are all rounded off to 3dp, like this. You got that? Yeah, that's how it's done, huh? All right. So now we got v squared. V squared is just the velocity squared. So now we have to go and show how to do the calculations for v squared. So del of v squared, right? Sorry, I like to do it this way. Let x be equals to v squared. So del x over x is equals to 2 times of del v over v, right? And therefore, del x is equals to 2 times of del v over v times x. And that means when you sub back this one into here, it will be del v squared is equals to 2 times of del v over v times v squared, which is equals to 2 times of del v times v, right? So it's a bit strange, right? Don't worry about the logo. That's my software. Okay, so send you to this one. Right, so this is your uncertainty calculations for del v squared. So I'm gonna do the same thing here. Plot. I think one of the reasons why I do this is because like it's so fast for me that I kind of like try to help you all to save time from trying to muck around with all these Excel things, right? Yeah, right. So it's like, my like half an hour of my effort will save you like a few hours. So I might as well just do it. But I think importantly is you look at the file and you learn how to see how it's done. Because Excel, right, is going to be a very useful tool for university and work next time. Like you go to work, right? You go to university, everybody will be using Excel. So yeah, so it's good to see how it's done. Right? Someone has to show you. Nobody will expect you to do how to do Excel in the first place. One. Yeah, lah, I see I think one of the cells was manually, the area was manually calculated. I saw that there. Okay, I have to round this off. Oh, looks like the first two are 2 DPs, which is fine. And the last few are 3dps. So it's perfectly fine, and it's actually important to be able to note that your values here is rounded off to your uncertainty. So if the uncertainty is 2 dp, you round it off to 3 dp. If it's 3 dp, you round it off to 3 dp. So it's okay to have differing dps like this. Alright, you see this, huh? Okay. So that's v squared. Hang on, let me just try to move this guy around. Okay, area is, so it's the square, so equals to 1 over the length squared. I know it's the same, but I need to be very careful with the dp's now. Okay, so let me just do this. Area equals to L squared. So del area over area is equals to 2 times of del L over L. So del area is equals to 2 times of del L over L times area. And therefore it simplifies to 2 times of del L times L, because area is L squared. So this is your uncertainty for the area. Eh, wait, okay. So uncertainty of area. Wait, but it's 1 over area. Does it make a difference? 1 over area is L to, okay, let me amend this, sorry. Area minus 1 is L minus 2. So del area over area is still the same. Powers rule is still the same. Yeah, same also, it's still the same lah. Yeah. Yeah, correct. It's still the same. Yeah, it's still the same. It's still the same. Okay, it's still the same. Just trying to figure out whether I made a mistake there. Right, so the uncertainty of 1 over area is equals to 2 times uh 2 times this uncertainty times the length itself. Then I need to round this off to 1SF. SF. Then I need to do this the same for this one here. So, oh, 4 decimal places. Okay, that's fine. Okay, there we go. No, maybe I have to double check this one again. Wait, let me think further. Don't think, just try. Hmm. Oh, it does look different. Like the uncertainty of 1 over A is actually 2 times del L over L cubed. Yeah. So you see, right? If I let X be 1 over A, then I want to find out what's the uncertainty of X. So it's del X over X equals to del A over A. Then I bring the X over. So del X is del A over A times X. But X is 1 over A. So I put the 1 over A down here. So it becomes del A over A squared, right? So del X is del A over A squared. On a side note, del A is found based on L. So del A is 2 times of del L over L times A. But A is L squared. So you have 2 times of del L times L. Then I sub this back into the del A. So it becomes here. So the del 1 over A, because that's the del X, the del 1 over A is equals to 2 times of del L times L over A squared is L to the power of 4, right? Yeah. So then the L cancels out, so it becomes del L over L cubed. You, you help me double check this. I think I need some eyeball on this thing. I don't know. But it does sound logical to me now, which means that I need to change this thing here. Because it seems a bit small for this. I don't know why. Yeah, so this is 2 times to the power of 3. Oh my god, it's even smaller now. Close to 2 times 0.001. Yeah, no, yeah, then, oh no, divided by, then divided by this one to the power of 3. Let me just bracket these guys up a bit. So 2 times. Ah, I think this is correct now. Yes, this will make sense. Yeah, yeah, this one here. This one here. Wow, this was complicated. Okay. But you have me double check your the numbers again, huh? Or you can just ask your teacher to check. You just say like, oh, I was doing this. Like you always approach your teacher by saying that, oh no, remember when you were teaching me uncertainties, right? I was just wondering if this is correct. Okay. We are trying to prove whether v squared is directly proportional to 1 over a. Is that right? E. Looks like Japan. Okay. So the graph here, linear r squared value 9769 is okay. A bit of scatter here and there. That's good. I think generally this is fine. Let me just double check. Eh? No, your area is should be on the y-axis. So x-axis. Area is on the x-axis because that's the independent variable. Then this is your y-axis. So let me just write this on this x-axis. This is y-axis. So I need to the way you select the cells, like the order in which you select the cells will change the shape, the axis one. Eh? I say that, but then yet it's wrong still. Right? Because 1 over area is on these numbers, right? These are the wrong numbers. Okay, never mind. I just go in and manually change it. Select data, edit x values. X values is these. Y values is these. Yeah. Okay lah. Oh, actually it looks nicer this way. Okay lah, still the same. Okay, there we go. All right, so now what we're gonna do is I'm gonna give you the max min gradient as well, based on the y values. So the y values are here. Okay, y yellow for y, yellow for y. Okay, this is the so that I don't mistake it. So we're gonna use the first and last data point. Oh no, not yet, not yet. I'm gonna give you your error bars as well. Error bars, x axis error bars. Area is the x-axis, so this x-axis error bars. Okay, there's also a chance that your teacher wants you to use uh, Logger Pro. Okay, there's a chance that your teacher wants you to use Logger Pro. If you hear them wanting to use Logger Pro, you just port the data over. Okay, but so what I'll do is I'll just give you a reference lah. Okay, so what I'm doing here is just give you a reference. The error bars, the vertical error bars are very, very small to be seen. So these ones here at the side here, these ones here, these are like the first data point, the top and bottom, last data point, top and bottom, which I'm gonna add into the graph. Yeah. Sorry, let me just try to get this out of the way. Okay, there we go. That will be like your max min gradient. Well, it depends. I may have to draw it manually on the Logger Pro. We'll see. Uh, but other than from that, I think that's it. That's a whole data processed already, right? Your final graph should look something like that. Okay, Ken? I know you got to run off. You got a class at 3:30, right? I'll send this to you. I'll try to find a report that you can reference. Right? Please remind me if I don't send it to you. Just gently chase me, right? Because sometimes I see your message already, but I'm out, and then I come home, then I forget, then just chase me again, and the next half a day later. Okay? All right. See you. Bye. You already show what? Oh no. Okay. Depends on how close you are to the teacher, I suppose. Yeah. Or you can just say that you did it at home. Oh? I don't know. Yeah, yeah, yeah. Just say that you did a few more trials at home or something like that lah. Yeah, no choice lah. Okay, Ken. All right, right. Any questions? You just let me know on WhatsApp. You just text me. It's okay one. All right. I owe you a sample IA. Okay. All right. Okay. See you. Okay. Bye. Bye. Bye.